Hello, proto-ghouls, dropped packets, and zombie processes. Halloween is almost here. What scary costume will you wear this year? Old school Freddy Krueger? A classic vampire? A howling werewolf? Client-side validation? Server-side JavaScript? A CVE? Or a path traversal that goes ... Which means this week we dig up some articles, lay some vulns to rest, and bury ourselves in Appsec news. Turn down the lights and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
Business Security Weekly is live streamed and recorded on Mondays at 2 p.m. Eastern Time. Each week, we address the challenges facing CISOs through our guest interviews, including former and active CISOs. Our news segment is focused on leadership and communication to better help security leaders translate and communicate security risks into business risks. Jason Albuquerque, Ben Carr, Tyler Robinson, and others add their expertise to the conversation. I'm Matt Alderman, and I hope you search for Business Security Weekly in your favorite podcast catcher and subscribe to download our latest content.
This is episode 305, recorded October 28th, almost Halloween, 2024. I'm your host, Mike Shima, and I'm here with Adrian Sanabria. Hello, Adrian.
Hey, how you doing? Always good to come on ASW.
Always good to have you here, and I'm doing quite well and in a good mood because Ghost just announced their European and North American tour. So that's what my summer is going to involve. And Adrian, we're going to dive right into the news. Our second segment is a pre-recorded one from Octane. So after I sign off, listeners, please do stick around and listen to that. But first, let's talk about some news with Adrian. So Adrian, I've got, once again, I jump around between vulns and designs and things that I find interesting. So let's hopefully you can follow some breadcrumbs with me. First off, Rust TLS outperforms OpenSSL and boring SSL. This is an article from Proximo. They've been doing memory safety, a bunch of really good refactoring, rewriting of projects, and they've been, as the name implies, rewriting a TLS stack in Rust. And we covered this a while ago, but now they have an updated post about it, and they're pointing out the performance is wonderful. The performance is actually even better than both OpenSSL and Boring, which is Google's stewardship of the OpenSSL codebase. And there are a couple of reasons I want to hit on this, but the first is the obvious one of just engineers do care about performance. If you, with your engineer hat on, Adrian, I said, it'll be more secure, do it for security's sake, I suspect I'm going to have a harder time convincing you. But if I say we can reduce latency down to, we're still stuck with that speed of light over our fiber optic cables that are wrapped around the earth, but reducing latency, better performance, fewer CPU cycles, these all sound like great things.
Yeah, I mean, it's so important. Like you and me probably remember a time when not every website used HTTPS on the internet. And one of the biggest complaints was performance. If we enabled that for everything, our website performance would suck. Our website would be slow. And, a couple things helped that, I think. I think performance just increasing on compute in general, like much more efficient compute, GPUs, there's products to offload, the cryptographic overhead of doing encryption work. And then Let's Encrypt was a big push, and Google adjusting your ranking based on whether or not you had HTTPS was another big push here. Performance is, and again, we see it with DevOps and things like that, where security opportunities have been created in search of performance. High availability, aiming for better uptime allows us to patch without bringing applications down. There's all these things that the DevOps world has done and cloud has enabled that great opportunities for security to improve security, immutable infrastructure, ephemeral infrastructure and credentials and things like that. All that stuff is just, we've got performance to thank for it and availability.
And I love, you gave me a good sense of foreboding or foreshadowing here for some of the other things we'll talk about, but I do love how you highlighted, yes, the aspects of software quality and performance are just peers, if not perhaps more important than security. And I say that with pure sincerity on an application security podcast, because just saying do this because it's secure misses those incentives that you listed, especially that Google search ranking. That's, a friend of mine used to have a wonderful joke: where's the best place to hide a dead body? The second page of the Google search. But there's another aspect of this article I wanted to hit on, is that yes, it's written in Rust, but under the hood, there's actually a lot of C, and there's actually even some assembly. Now, it's auto-generated assembly, but it's not a pure 100% Rust. And I wanted to point that out, not because I care about some pedantic reason that this has to be a pure Rust stack, but pointing out that it got the performance still because of C. C is not going to go away even as we move to memory safety. But the idea of being able to compartmentalize or break down something like a TLS, like OpenSSL, into different components and say, here's the component that users often misuse, like the API service, or if we hand them how to deal with blocks or memory, areas of memory, let's do that in Rust, because it's a lot harder for them to make mistakes. It's a lot harder for them to misuse that API. And I think that's a good thing. So I don't care that, technically there's still a little bit of that C sneaking out under here. I think all this is a good direction and very reasonable software architecture.
For sure. And there's also some foreshadowing here in terms of, you should do this just for security's sake, where there have been so many vulnerabilities for SSL, TLS over the years, and yet we've never heard of a breach where somebody took some encrypted in transit traffic and used that, tried to decrypt it or used any of these vulnerabilities.
Yes, that's where we're getting into the Five Eyes networks, and that's where you have intelligence agencies who care and have that store and decrypt later. And I guess the other thing I want to point out too, I don't think we need to go into the side channel of quantum encryption or quantum computers, because I think the only reason I want to mention that is because you're talking about decrypting traffic. AES isn't going to be broken by quantum computers. It's these handshakes. It's a lot of the factoring. And that's one of those things that there's a bit of mythology out there about quantum computers will break all the encryption. And I want to make sure that we are very clear about this, about what is actually a risk and what's not. But
stuff that's based on Shor's algorithm, I think it's called.
Mm-hmm.
Yeah, the stuff that's so stuff you use for code signing, stuff you use for public-private key. So that the stuff that we use to set up and to encrypt HTTPS sessions is included in that. And also worth mentioning, a lot of that's already out there. If you're using Chrome today, if you're using an Apple device, you've already got post-quantum algorithms on your devices. So we're already deep down that path of replacing those older protocols.
Before we continue that path, you did mention vulnerabilities in OpenSSL. Everybody, the first thing that comes to my mind is the ancient, I think it's a decade old now, Heartbleed. But here is another article from that was found by, I'll hold that for a second. Here's another article about OpenSSL, a security advisory. It's a very low risk of vulnerability. Even in the disclosure, it says, quote, any problematic use cases would have to be using an exotic curve encoding. And this really just means, as you were pointing out, things like ECDSA, there's only 3 algorithms basically that everyone is allowed to use per spec, or is going to use per the spec. So it's not like there's an exploit case here waiting to happen. But what stood out for me for this is that it was attributed to Google's OSS fuzzgen, which I think is wonderful. And this I just love to point out is that this year especially, LLMs, generative APIs, generative AIs, are like, oh, these are the cool things. This is the future of security. I still love fuzzers. Fuzzers themselves, I think my hypothesis holds up of CPU cycle for CPU cycle. I think investing in fuzzing is much better than investing in LLMs, at least in the current state of the art in 2024, because those fuzzers are going to find a software quality issue. It's either going to be a crash that you should fix, or it's going to be a crash that's also exploitable that you should fix. It also just happens to get probably a CVE or some security advisory associated with it. So that article is more of a chance for me to extol the virtues of fuzzers and not forget them in 2024.
So I've seen LLMs used for fuzzer input. We actually had a high schooler give a presentation at B-Sides Knoxville, and that is on YouTube now, so you can go watch that. And she used, I think it was mainly ChatGPT to generate rules for SemGrep. And, she was kind of comparing like the existing rules that people had built with these that the LLM had helped her create. And it was pretty impressive.
That is pretty awesome. And I love that because I will concede that trying to build the corpus of what's the input that the fuzzer should start mutating can be tedious. And also just having an LLM watching the fuzzer and tuning it sounds like a great idea. So we'll definitely get the link from that presentation and throw that up into the show notes as well. One more article about TLS, and then I promise we'll move on to other things. But Apple, like Google, wants to reduce the lifespan of TLS certificates. Now they're get it down to the current, well over a year, to 45 days by April 2027, and then a certain type of domain validated certs down to even just 10 days. I, for one, think this is awesome. It's good. I understand the pushback of, wait, we have to rotate keys all the time. These certs, this sounds like it's going to be a hassle, a nightmare. And my response to that is kind of what you already pointed out. Let's Encrypt. Let's Encrypt is a wonderful project that I think provides the two economic solutions to this. One, certificates can be free, but two, the overhead of managing those certificates can be reduced. I won't say it's free, but their Acme protocol, a lot of their primitives they have, makes this a lot easier. So this feels like an optimistic future for me, and I hope this does continue forward.
Yeah, we're already at API version 2 for Acme, and Google is pushing for 90-day max certificates in Chrome. They're talking about putting that into Chrome, where they will not accept any certificates longer than that. So already, Chrome is so dominant, they could enforce a change like that. And you should be fully automating certificate management. I think it's nuts to try and do that manually today. There's so many free tools out there. There's commercial tools. Most of it's agent based, but it's pretty simple stuff. You can code up your own, like you said with Let's Encrypt. It's pretty painless.
Pretty painless. It's not free in terms of time and effort, but I think it's minimized, right, as you were pointing out. And going back to incentives, if the Chrome browser is doing this, and then also Safari, that's kind of just a de facto enforcement that sites are going to have to follow. So there's definitely a call it a forced migration from that perspective. And I think the other thing I would add too is that there is, like with SSO, there's the SSO.tax site, which I'm sure you've seen before, as people saying, oh, why are we being charged a premium to support SSO rather than just the basics to implement its support? I wonder if we'll also see a TLS.tax emerge as well, because I will concede that some organizations might be reliant on their vendors to update and rotate certs. And that will be one of those sticky situations. But again, it's not like those vendors don't have access to Acme, Let's Encrypt capabilities, et cetera. It's just how do you exert that pressure? How do you get those incentives for others to change for you?
Yeah, and you're doing some foreshadowing yourself for the Secure by Design article.
It is. Before we get into Secure by Design, let's continue a little bit of the past, because I mentioned like TLS 1.0. I mentioned we've just been talking about TLS and transitions. I also had an article here from the AP NIC about the IPv6 transition. And this initially doesn't actually have an immediate AppSec tie-in but it is a great article that's a summary of the history of IPv6, which the first specification, as it points out, was published in December 1998. So this is already 25 years ago. That's literally the era of Windows 98. And if you knew the movie You've Got Mail, if you're a fan of Tom Hanks, Meg Ryan, or even AOL, to dust off some history, that just gives you a sense of how far back that goes. But this article points out that IPv6, despite over 2 decades, still isn't universally deployed. And it's very hard for like an ISP to say we're IPv6 only, because there will be quote unquote dark areas of the internet that are only reachable via IPv4. The reason I brought this up is because I think there are AppSec parallels. Very specifically, we've been talking about TLS already, and there was a long time where a lot of security conferences, DEF CON, Black Hat, others were pointing out, here's a flaw in TLS. Here's a beast, a poodle, a crime, all those fun acronyms for different TLS attacks, and saying, and kind of taking the shame approach of, you're not supporting HTTPS. I think what was more impactful, however, was something like the PCI DSS that required sites to deploy a better default of TLS. And the other thing was Let's Encrypt that you mentioned already, that just provided, rather than shame people into saying, start using TLS, Let's Encrypt came along and said, here's how to do a little bit easier, both free certs and pretty free or close to free ways of automating the overhead. So that was kind of the AppSec tie-in there. And generally, we could talk about just other types of migrations, getting off of HTTP 1 onto HTTP 2, HTTP 3. But none of these really have, other than TLS, a very strict security component to them. So that was just kind of my food for thought this week. And so I don't know, was that some tasty food for thought to butcher that metaphor, Adrian, or does that bring anything to mind for you in other types of transitions?
Yeah, IPv6 is interesting because it, like you saw the government make that transition quickly because they were required to. They were mandated to switch over to IPv6. And I remember going to a talk at a very early security conference here in East Tennessee that was put on by UT Knoxville and the Oak Ridge National Labs. And there were actually some security downsides to moving to IPv6. Like one of the things I realized as the guy was talking about it was that ARP route poisoning, where you can insert yourself as you can pretend you're a router and sit between point A and point B and capture the traffic. Typically on an IPv4 network, you're limited to a single subnet with that. But on IPv6, you can do it for the entire private network. So I thought that was really interesting. But yeah, we're now seeing protocols mandating it. So if you do any IoT work or use IoT devices, I'm pretty sure for Matter or Thread, which are the newest protocols for IoT, require IPv6 support to be able to do that, and just makes it simpler to deploy these things, and makes it simpler for the user too, because they don't have to worry about NAT. And, if every light bulb in your house has an IP address, even the typical default class C, you're not going to run out.
Yeah, and you mentioned too, like NAT and the address space concerns, and even just what's this? Is this an evil? Does this IP address, IPv4 packet, have an evil bit set into it? Which I can't remember the RFC, but it's a fun one. But I think what this article also points out is call it the threat model or the use cases. Perhaps there's slightly fewer threats around the IPv6, but that changes over time in the sense that early on, a lot of internet security was based on, do we trust this IP address, or this IP address equals identity? This is the IPv4 address that represents Adrian, and do we think he's a bot or not? Do we think this is trustworthy? In the world of something that rhymes with hero thrust, we've gotten away from the idea of the IP address is an anchor to identity or an anchor of security. And the article kind of points that out, as well as pointing out how NAT helped us save on the address space to a degree. And I think I bring those up because I think there are metaphors there with security mitigations. If we as an AppSec team go and say, you have to go and replace this, you have to do XYZ because of security, that security threat model might change over time. And there could be other mitigating things you can throw in there rather than just rewrite a code from scratch. So that's my...
I think the real lesson here is you need strong incentives if you want somebody to transition from old to new, and we see it forced with like smartphones, for example. You just stop getting updates. You can't use the latest fun stuff. And, with IPv6, the government mandated that government organizations would have to switch to it. Nobody else was mandated to, and they didn't, because that exhaustion never really occurred. And the cloud kind of made it easier to handle IPv4 addresses, and I think made it less likely to have large batches of unused addresses. So, yeah, I mean, and you know what? It's fine. I mean, you can secure stuff with an IPv4 address. There's still not sufficient incentive, I think, to move everything to IPv6.
Indeed. And I guess on the other side, I will say, hopefully we start seeing more sites move to just TLS 1.3 by default. So in the spirit of migrations, we'll come back a year from now and just take a look and see what metrics we can come back with that. Now, Adrian, you mentioned too some secure design. So let's combine maybe two of these articles here. One is, in a broad sense, from the Google security blog, 7 ways we're incorporating security by design into our products and services. And then on the Trail of Bits blog, a very specific and narrow example of a deep dive into Linux's new MSeal syscall. So a very specific example of secure design. These are interrelated, but I've been doing a lot of the talking. Let me throw over to you. Which one do you want to start with first to pick on?
Let's go with secure by design.
Yes. So in this one, I'm pausing because it's just, I wanted more out of this because some of the things are designed, like reducing entire classes of vulnerability. Big thumbs up from me. To talk about default passwords, you mentioned IoT devices. That's a huge
SQL
aspect
injection
of
should
IoT.
not exist anymore.
Yes, exactly. But then there's some other things about this that are secure by design, but they're more about process, and they touch on the full life cycle of software, like vulnerability disclosure, using CVEs, evidence of intrusions. And I don't think that's bad, but that's not necessarily part of the software design, like the architecture. If you're talking about the AppSec approach to what you're building rather than what you're curating with you build. And I don't know if that's if that's necessarily an important distinction to make, or where you would kind of take this type of article.
I mean, one thing that kind of bugs me, the most popular Medium article when I used to publish on there that I ever wrote was a list of things you could do to make sure somebody didn't have access to your Gmail, right? So I went through all the different ways you could tell if somebody had put in some kind of forwarding rule, to send your email somewhere else. And one of those is, API keys, giving access to Gmail via API. And I think years ago, I'm trying to remember the name of the plugin, but it was a plugin designed to unsubscribe you from all newsletters and emails and stuff like that. And it had unsubscribe in the name. I forget exactly the name of it, but it was very controversial because they had sold access to the access they had to people's Gmail accounts to Uber, because Uber wanted to see when people were signing up for Lyft. They wanted to see that timeline to see when people stopped using Uber and started using Lyft. And Google talks about transparency here, but when I give one of these plugins access to my Gmail account, I can't see if they've read one email or if they've read all of them. I have no transparency into what is going on behind the scenes when I give a third-party access to my stuff. And to me, that's more secure by design than anything they're talking about here. Is because again, with Microsoft, so many examples with Microsoft where Microsoft didn't have enough logs to see when China hacked in, to do that famous breach that the CSRB, the Cybersecurity Review Board did.
Avoidable failures, a wonderful phrase out of that report about Microsoft. Yeah.
Yeah, and recently they lost 2 weeks of security logs for all customers. They're just gone, and there's just a lot of this. I hate stuff that puts the onus on the user, right? I think secure by design should be more about default being secure by default than here's some work you can do yourself, like applying the security patches. I think one of the most impactful things is when Microsoft decided, you know what, we'll just make reboots painless. All your stuff will open back where it was. You won't lose any data. And we're just going to automatically reboot your computer, for at least for consumer versions of Windows by default. And that's been a huge change. Often I can't even tell that my computer's been rebooted, except maybe there's a couple programs running in the background that I usually close because I don't want them open all the time.
And that part, I think, CISA likes to use the phrase, I think it's, take for software developers to take responsibility for user outcomes. And I think that's a lot of what you were describing, that the idea of secure defaults should just be there. The idea of a hardening guide is an anti-pattern. A hardening guide should not exist anymore. They should be a loosening guide, if you will, in the sense of, if you really want to use this feature, or if you want to weaken the default security because your environment needs it, because your use case needs it for whatever reason, here's what you do. But by default, everything's secure. And as you're talking about engaging the user, there is definitely a delicate balance between giving the user that transparency. Here are the IP addresses, for example, who have used or accessed your account, but giving that IP address a degree of geographic identity, but also trying to do that in a way that's not just scaring people or confusing people, because if they live in one region but their ISP shows up as a different city, that could potentially be confusing. So there's a balance there, but I definitely, like you, err on that side of transparency. And even going back to the Google examples of, call it misuse, they got in trouble a while ago for having phone numbers that were used for SMS and MFA, then just being marketed to and used for non-security purposes, or the non-original purpose that those phone numbers were collected for. So again, another example of putting the burden on these software creators to treat users better, I guess, for lack of a better phrase.
And again, there has to be incentives, right? Like I remember when Slack was new, and there were all these Slack competitors, and SpiderOak, a company called SpiderOak, came out with a secure Slack competitor. And I would challenge anybody to remember what the name of that product was. I think there's some form of it that still exists, but they pivoted into space security. They're making software specifically to be used in space. So really weird pivot, but there just wasn't enough incentive there. And you hear people outraged about choices that Slack makes, like, by default, the administrators of a Slack can read DMs or something like that. Or, like we just recently on one of the Slacks I'm on had some issues with the Slack connections, I think they call it, where you can connect Slacks together. Somebody from another Slack we didn't even know was connected to our Slack was sending sales pitches over DMs to our Slack's members, which is like rule number one of this particular Slack, because it has a bunch of security leaders in it, and it's supposed to be a safe space where you're not going to get attacked by salespeople. And they did because of this. And we all complain about that stuff, but we keep using it, right? Like it's not enough to drive us to some kind of Slack alternative. Just because it has that momentum. And founders know this, investors know this. And I think secure by default is fine for big tech, that can afford it. But a lot of these startups, I'm not sure there's any great examples of a company doing secure by default from seed stage on up and succeeding with that, right? Like all the examples I can think of, like Dropbox is the one. I love to see if people know how many breaches Dropbox has had, because they had a ton, but none of them really slowed them down. None of them really slowed their growth.
Yeah, and I think one of the space security, I just want to see zero trust and zero G, and that sounds like fun stuff to work on at least. But you're pointing out the where are the incentives using this, but also even that Slack example of connecting different spaces, that to me speaks very directly to business logic or an area of application security that doesn't appear on any top 10 lists or top 20 lists or whatever, in the sense of we as the industry love to talk about input style attacks, cross-site scripting, SQL injection that should not exist anymore, as you said, command injection, other things that are just, we're mucking about with some data and we're seeing what garbage comes back, like an XXE attack even, or my favorite, path traversal. But there's a lot of things around this logic. How is this being used? How can it be abused? That I think needs more of an appreciation and more attention within a product security team. And those are the areas I really like.
Yeah, and the worst vulnerabilities come out of companies that aren't software companies, weren't born software companies, and or don't have somebody on their team that has that kind of middle schooler, high schooler mindset of how can I abuse this to do something
Totally
do something silly or ridiculous with it. And there's lots of examples of that in the market where just really, really basic vulnerabilities pop up. And, of course, it's a company that traditionally makes appliances or something like that, or kids' toys, or whatever it might be. But yeah, I think that threat modeling mindset, that abuse cases mindset is necessary to have in there, even if you're not going to go full on secure by design. And there can still be some really bad outcomes for your business, especially like kids' toys. Like, I don't know how many parents stopped buying those, was it Leap or VTech maybe, that had they had like a little toy laptop, but kids could take pictures with it and it connected to the internet, and they found all the photos were just wide open on an S3 bucket or something like that, or on the website, and you could just scrape through all of it. So, there are some cases out there where, I think loss of trust could have a big impact on revenue.
Absolutely. And I think we're going to come back to another article about finding such vulns, or well, not finding simpler vulns, I should say. But before we do that, there's also that idea of, let's talk about incentives and reducing classes of attacks, or at least mitigating classes of attacks. So I threw in here a deep dive into Linux's new MCL syscall. This is from, as I mentioned before, that Trail of Bits blog. And I also linked to a LWN.net article that was introducing this feature, which is basically saying MCL is memory sealing, and it's designed to mitigate memory corruption issues. So if you as an attacker have a pointer that you can corrupt, and then influence that pointer can point to some executable code, memory sealing is a way to say this area of code is non-executable and it stays non-executable forever, or it's read-write, or it's read-only, and it stays read-only forever. It's been sealed for freshness. And what was interesting about this, digging into it, again, really good blog write-up from Trail of Bits, as typical, but the use case really just comes out of the Chrome team, who wants to use this for, understandably, improving their V8 engine and being able to help and protect how all their JIT engine is handling JavaScript. So it's good, but it kind of only has one use case for one, admittedly, big user base, large attack surface of Chrome. And it says that ideally they'll apply this to glibc so that other applications can benefit from this by default. But it seemed interesting to me that maybe this isn't so much incentives as it is just influence, perhaps. But here's a feature. It will protect Chrome. It's making adding some complexity to the Linux kernel, but it's not benefiting everyone else yet. And I did throw in that yet to be optimistic, but hopefully we see more of this than just using Chrome.
I love the concept of mitigations, and I think they're generally more valuable than most of what you do in vulnerability management. Because you've got to accept that there are going to be vulnerabilities you're going to miss, you're never going to get to. And mitigations like this can help protect you when that happens against, 0 days and stuff you're not aware of, or maybe you just don't get to and don't get fixed or patched. And this is, kind of reminds me in a way, metaphorically, like the problem of session keys. The fact that I can take your Slack OAuth key or whatever that auth token looks like from your computer, put it on my computer, and now I'm logged in as you. And, that bypasses the whole authentication process, including MFA. Seems crazy to me in 2024 that we can't detect or can't link a token to a device. I mean, it's very handy in that upgrading to a new iPhone or a new Windows system, you don't have to log into everything again. That's very convenient. And it's kind of a pain to, having just upgraded my iPhone to have to re-log into things. But I did notice on my iPhone, some I had to re-log into, some I didn't. Some were already logged into after I made that transfer. But mitigations are really important. And stuff like this seems like we should have had it a long time ago.
We should have had it a long time ago. Sounds like such a slogan for AppSec. I agree. It feels a little pessimistic, so I may not embrace it too wholeheartedly. But you mentioned like that you made a great point. Like, I love extolling the virtues of passkeys. As we started off this particular segment, I was talking about Rust. Two things I love talking about. I will still point out that most web applications are built in with a memory safe language. So there's a lot of vulnerabilities, SQL injection, cross-site scripting, not memory safety issues. So there's a lot of things that memory safe designs don't address. And even passkeys, as you rightfully pointed out, steal that session token and you can start to impersonate me and find out like what fun Slack channels I'm hanging out in. The good thing is that Chrome, going back to them, are working on like device-bound sessions. Safari, Edge, both have similar approaches for trying to address this problem that says, you've logged in and this cookie now lives in that secure enclave. And it's not going to be extracted, but it can still be used to demonstrate identity to that website. So now, if you steal that token, it's not reusable. It's getting closer to that idea of, call it like universal PKI. Everybody has that public-private key pair in a way, and that private key actually stays private.
Yeah.
We're going to move now to a couple wrapping up here. Let's switch back to finding those vulnerabilities and see what the kids are up to these days. Here's an article from Vulns, and the title of the article is "Autonomous AI Finds First Zero-Day Vulnerabilities in Wild." Now, that sounds a little bit hypish, but give them a lot of credit. It's a very well-written article. I think it's a very balanced article in the sense that, yes, Vulns and team, they have a repo where they showed how they wrangled an LLM into finding about a half a dozen or so classes of vulnerabilities in Python code specifically. But what was really interesting is they also walked through, call it hurdles, call it challenges, some of the things where the LLM wasn't the best thing ever. They point out LLMs aren't deterministic, so you might have to rerun the tool multiple times just to find a particular cross-site scripting if you were initially focused on SQL injection, for example. They had tried to look at RAG, but RAG wasn't actually working for them. And RAG is one of those things that are extolled about setting feedback loops. I'm not trying to say here an anecdote of one disproves that RAG is going to be useful, but just pointing out that there's a lot of messy engineering that needs to go into here. And really, I wanted to highlight this as something to check in like 6 months later that John and I often like to do about what's the state of this now? Is it finding meaningful, impactful vulns that you can't find with just a grep? Right. Or just as I was mentioning at the top too, that fuzzer? Because again, LLMs really expensive, CPU cycle wise, etc. I think, and I want to hope that my hypothesis holds true that fuzzing is the way to do it economically and effectively. So I'm not sure what your reactions are to something like this. Are generative AIs and LLMs our future?
Well, one of the biggest problems we have with vulnerability management is that most published vulnerabilities are worthless. They represent no risk to the organization. So the signal noise ratio is really bad. And there's just not a whole lot of value in vulnerabilities. So yeah, sure. I'm sure you don't even need an LLM to produce tons and tons of vulnerabilities. I'm really worried about the bug bounty platforms that are going to have to triage all this garbage that just
Seen
gets,
that already too. Yeah.
yeah, that just gets auto pumped into it, right? And rightfully so. If somebody does do that, the platforms do have a way of rating the people, like, the ratio of useful vulnerabilities or accepted vulnerabilities to rejected ones. So that should tank your crowd score or whatever they call it on these different platforms. But yeah, we very much need quality over, like, if they then paired this with some kind of validation that it was able to do something critical to the application, I think I would put more value on it. But I just look at this and I see a noise generator for the most part.
And in the article, one of the other reasons I highlighted it, they admit up front that they even have like basically a confidence score. Do we think this is probably a vulnerability that you should address, or it's probably a critical, probably impactful, or it's probably
it's not what you think,
not.
though. It's not how serious the vulnerability is. It's whether or not it's a vulnerability at all.
Yes.
So yeah, you could have a 10. Absolutely, this is a vulnerability. But it would have a CVSS score of 3, right?
Yes, thank you.
Yeah, so that says nothing about the quality of the vulnerability or the severity of it.
And that's where, too, one more quick aside on fuzzers is that fuzzers, if they do cause a crash, maybe that's not an exploitable security vulnerability, but it was a crash, and that's points to a bug and a software quality issue to address. So I think even if it's not producing immediate security vulns that are CVEs that you care about, it's still producing something that, from an engineer's perspective, you do care about to make the parser stronger, add some better error handling, exception handling, etc. So again, those are some, call it the failure cases of a fuzzer are still beneficial.
I think you're being fuzzed by your cat right now.
Black kitty for Halloween. Here we go. While the cat tries to play with the microphone, we have another quick article about, we've been talking about CVEs, Adrian, and it just so happens that the CVE program is celebrating 25 years of impact in cybersecurity. Now, this is one of those things that I love this title because it's celebrating impact, but it doesn't say, is that positive, negative impact? It didn't quite put an adjective in front of that. But I'll politely and playfully tease CVE a bit, just to point out the article. Happy 25 years. But ask you, Adrian, do you have a favorite CVE? Do you even know any CVE numbers off the top of your head?
Yeah, I do, actually. Anybody who's worked as a pen tester, done network-based penetration tests, probably can roll a few CVs off the top of their head. And, for my generation, it was MSO 8067, which worked all the way back to NT4 and was never patched on NT4. So if you find NT4 today, you can use MSO 8067. It's very reliable in that it works every time. It gives you remote code execution every time. And, the newer one in that category is probably Eternal Blue, which pen testers are probably still finding on almost every engagement of an organization with 5,000 or more employees. And putting on my pen tester hat, those would be my favorite. From a more from coming at it from a different perspective. We were talking about we could have award categories for CVEs, and there have been a lot that I think caused more harm than good. Like you couldn't pass PCI if you had Beast, Crime, Poodle, Freak, any of those SSL vulnerabilities. But there was no advantage to applying those patches and upgrading SSL and TLS. And that was just a constant thing that went on. Like you were just constantly having to upgrade your web servers and to deal with the latest TLS version, either to move to that or to enable and disable the correct protocols within each of those. And no, they didn't call them protocols. What they call them, the different cipher suites. We call them cipher suites. And then I think Meltdown Inspector gets the award for the most damaging CVEs. And I think that was a group of maybe 3 or 4 CVEs. Side channel attacks that there was some rumor that maybe there was some RCE, and they could have been really bad if there was RCE with this, because it would have been like something like Heartbleed, right? where you just can target the site directly and get bits of memory or remote code execution or something like that. But they all ended up just being privilege escalation. So you needed root on the box before you could do anything with them. And they destroyed performance. A lot of the patches didn't work out of the gate. Some of the patches broke things and impacted just about all infrastructure everywhere. And like an overall performance hit of like 20, 30%, I saw estimated in some places. So these were, I think of them as academic vulnerabilities. Yes, they are technically vulnerabilities, but they had huge damaging impact to the industry with no upside.
Yeah, and I think you also highlighted, perhaps I'll frame this as, who cares about the vulnerability? Because the cloud service providers, they're going to care much more about the Spectre class of attacks because they have shared tenancy. They're sharing those CPU resources, they're sharing those compute resources. So you don't want those types of information leaks across tenants, for example.
Right.
But if it's in your own, if it's in your own environment, go fix all of those SQL injection, I say with a long sigh, or cross-site scripting. There's a lot of other bugs to fix before you're worrying about Spectre on your own. And for me, I definitely have to remember names more than the CV numbers, and Heartbleed would be the one that I would point to there as perhaps a favorite, the most maybe most disruptive or impactful for a long weekend for a lot of sysadmins out there. Definitely not the most pointless of them if we're coming up with categories. But you can also have the most fun finding CVEs in weird areas. And those weird areas often are hardware devices. So here's one article I did want to end on, Adrian, from 404 Media, which is quickly becoming one of my favorite sources of news.
Same.
And
I'm a subscriber.
Yes, please do subscribe. Support good tech investigation, tech journalism, because
it's like 5 journalists.
Yeah, and they're doing things like finding impactful ways demonstrating how products are being abused for users, how products are impacting negatively, to throw those important adjectives in there, users. They're also highlighting things that are fun in the sense of, here's some weird hardware.
Dog stories.
Yes. Can it run Doom? Now, I'll throw this over to you because I can tell you really want to talk about this, Adrian. But I do want to set this up as that it is a skateboarding dog, as you like to say, or can it run Doom? But there are some other aspects of this, like what are the DMCA aspects or the legal aspects to just repair your own tractor or a train, things that we've covered with John in the past, or of course, even McFlurry machines. So here, with that set up, please take it away, Adrian.
Yeah, no, I love right to repair and stuff like that, mentioning the McFlurry. So it was funny seeing that, McDonald's are allowed to repair their own machines now. And I think iFixit put up some repair guides or something like that. But yeah, this one's about Redbox. So Redbox, I think everybody knew it was going to die at some point, but they were going to let it hang out until, as long as it kept making money. But they're in bankruptcy right now. And it's kind of messy in that everyone that has one of these Redbox machines sitting outside their store, whether it's a grocery store or a CVS or a Walgreens or something like that, is kind of stuck with it, and these are big, heavy machines. And so people have realized, there is some nostalgia around the Redbox machines. And probably the kind of person to have some arcade machines or pinball machines in their basement are going out and seeing if they can pick up these things. And in many cases, picking them up for free because it's going to cost these organizations money to get rid of them. And so naturally that leads to projects, nerdy projects, like people wanting to fully document and understand the software inside these things so they can then use it as like basically a storage library for their own media collection, for their own video games and DVDs and Blu-rays and stuff like that. This would be an efficient use of space because that's basically what it was designed for. And I still haven't seen any details of what hardware it runs on or what the OS is. I'd say it's almost certainly some kind of Linux-based OS. I would be shocked if it was anything other than that. But yeah, it runs Doom. Obviously, that was the first thing somebody had to run on it. And yeah, there's a whole Discord community called Redbox Tinkering now. So yeah, if you want a fun project and don't mind moving around heavy things, go get a hand cart and a pickup truck and see if you can grab you one of these.
Absolutely. It just sounds like some fun, really just classic, let's say pure unadulterated fun hacking. Here's a device, who knows what it is, how it works, and let's figure it out. And so it's really fun just to follow that. So yes, we'll be excited to watch this, and we'll find some AppSec lessons to learn from these so we can continue to cover them.
Oh yeah, maybe they'll find some private keys, stuff like that. I think they did find some customer information on some of them, but it was only the customers that used that thing, so they could see like what you rented and when. So I don't know, maybe some weird and embarrassing rental patterns pop up online. I don't know. We'll see.
Yes, and hopefully they've already been extracting like AES keys, things like that. So you can see that. And since we're in the Halloween season, if you're interested in renting some movies, there's a bunch of good classic ones. I don't know. Let's see if maybe I'll put you on the spot, Adrian. Any recommendations for a horror movie to watch this year?
For a horror movie, I really like The Cabin in the Woods. That's a great one. That's kind of different approach to it. I know the director is not as beloved as he once was, but that's a different topic. I will say my favorite Halloween story is a Ray Bradbury short story called The Halloween Tree. And I give out free copies of the book every Halloween, and it's my favorite Halloween story. So yeah, it's going to be maybe not a movie, but a book. The Halloween Tree, I think, is just really kind of captures the classic Halloween vibe and feeling. It's about a bunch of boys that go trick-or-treating, and they end up going through the entire history of Halloween across like 7 different cultures. So like Mexico and Old Britain and Egypt and, just the history of celebrating the dead. And it's really well done. I love it.
Well, that reminds me to throw a link up to that is a good recommendation.
There is a Hanna-Barbera animated version of it, and I don't think I've ever watched it, but you could consume it in that form also. But I used to read it to my kids every Halloween.
Very fun. Yes, we'll go and read words now, on paper. Yes, we'll nerd out. No AppSec homework this week. Just some fun reading suggested by Adrian. So thank you very much for that, Adrian. Appreciate you joining us for the news this week.
Yeah, my pleasure.
Want to thank everyone else for joining us as well. Remember to subscribe, share on the socials, check out the show notes. And speaking of things Halloween and ghostly, check out Ghost Machine by Zarina. We'll see you next time on Application Security Weekly.